Hello everyone, this is Shrawan Sir, making maths simple for you. Welcome to my YouTube channel Karna Maths Academy. Today in this video, we are going to prove some of the important proof that of the formula which is from the chapter of coordinates in space. Here we go. Dear students, in the previous video, already we have proved the distance of any point from the origin, which is given by the formula d is equal to root x square plus y square plus z square. Dear students, this is the second proof that in this in this question we have to prove the distance between any 2 points in the space is given by the formula d is equal to root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Here we go. Dear student, at first let us draw a diagram to prove this formula. Dear student, let us draw x-axis. Dear students, at first let us draw three mutually perpendicular lines which are also known as x-axis, y-axis and z-axis. So dear student, at first we have to draw three mutually perpendicular lines OX, OY and OZ, which are also called x-axis, y-axis and z-axis. Now, according to the question, we have to prove that the distance between any 2 points p x1, y1, z1 and q x2, y2, z2 in this space is given by d is equal to root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So dear student, here in this question we are given 2 points because we have find the distance between 2 points in the space. So let us take point P and point Q, the given 2 points in the space. Now from the point P, dear student, now from the point P, we draw a straight line perpendicular to xy plane. Again from the point Q, we draw a perpendicular line on the xy plane. Dear student, now let us say dear students, let us say PM is perpendicular to xy plane and QN is also perpendicular to xy plane. From the given point P and from the point Q, we have drawn two perpendicular lines PM and Q1 in the xy plane. Dear student, from the point M and from the point N, let us draw perpendicular to x-axis. And again, from the point M, let us draw and again from the point M, we draw perpendicular to y-axis. And from the point N, also we draw perpendicular to y-axis so that we can locate the x and y coordinates of the given point. Dear student, x1, y1, z1 is the coordinates of the point P and the coordinates of the point Q is x2, y2, z2. Now let us join P to Q. Let us join P to Q because we have to find the distance between the point P and Q. So dear student, let us say OA. OA represent the x coordinate of the first point P, because from the point P we have drawn perpendicular to xy plane, and again from the point M we have drawn perpendicular to x-axis. So dear student, OA represents the x coordinate of the point P, that means x1, and OC represents the x coordinate of the second point Q, that means from O to A we have x1 and O to C we have got x2. So dear student, let us produce the line BM to meet the line CN at the point D. So dear student, again let us produce the line AM. Let us produce the line AM to meet the line DN at E. So these are the constructions we need to find the distance between any 2 points in the space. So dear student, if OA is x1 and OC is x2, then AC, the length of AC will be x2 minus x1. Again, OB and AM, they represent the y coordinate of the first point P, that means y1. Dear student, OD represents the y coordinate of the second point Q. So O to D we have got y2. So the difference between y2 and y1, we get y2 minus y1, which is the length of BD, which is the measure of BD. Now BD and DN both are equal, so we can write BD and DN both y2 minus y1. So this is y2 minus y1. So dear student, let us take one more construction. Now if we join M to N, dear student, if we join M to N, then we can find the length of Mn, because the measure of Dn is already found y2 minus y1, and the measure of MD is equal to AC. So MD, the measure of MD is x2 minus x1. So dear student, now by taking right angle triangle MDN, right angle at D, we can find the length of MN, which is the hypotenuse. So let us use Pythagoras theorem. H square is equal to P square plus B square. So dear student, in the right angle triangle MDN, applying the Pythagoras theorem, that means H square is equal to P square plus B square. So perpendicular, let us take as MD and base as DN, and hypotenuse, which is opposite to right angle, so hypotenuse is MN. So we can write this as MN square. And perpendicular, let us take MD as the perpendicular and DN as the base. So dear student, MN square will be equal to, let us put the value of MD and DN. the value of MD, or we can say the measure of MD is x2 minus x1, and the measure of DN, which is equal to y2 minus y1. So dear student, by using the Pythagoras theorem from the right angle triangle MDN, we have got the measure of MN. We have found the distance between MN, or we can say the length of MN. Now, let us draw. Let's take one more construction. Dear student, from the point P, let us draw perpendicular line to the line QN. So this is the last construction now, because we have find the distance between the given 2 points P and Q. So if we draw PR perpendicular to QN, then PM and RN will be equal. A rectangle will form in this space, and we know that the opposite sides of a rectangle are equal. So dear student, we know that PM represents the Z coordinate of the point P. So this PM is equal to Z1, and since PM and RN are equal because they are the opposite sides of a rectangle, so RN is also equal to Z, and QN from the point Q we have drawn perpendicular QN to the XY plane. So QN represents Z coordinate, that means Z2. So QN is Z and RN is Z1. So from Z2, if we subtract Z1, then the remaining will be Z2 minus Z1. So dear student, the difference between QN and RN, which is equal to QR, and the measure of QR will get Z2 minus Z1. That means the difference between the Z coordinate of the point Q and P, we get the measure of QR. So now let us take the right angle triangle PQR. So dear student, already we have found the measure of MN. MN and PR, they will be equal because a rectangle has been formed in the space, and we know that the opposite sides of rectangle are equal. So MN and PR both will be equal. So dear students, let us take the right angle triangle PQR. In the right angle triangle PQR, in the right angle triangle PQR, or we can say PRQ, right angle at R, H square is equal to P square plus B square. So dear student, now in the right angle triangle PRQ, the side opposite to right angle is the hypotenuse. So PQ we can take as the hypotenuse. Let us put the value of hypotenuse. Perpendicular, let us take PR as the perpendicular and QR as the base. So dear student, if we substitute the values, if we substitute the corresponding values of PR and QR, so let's substitute the value of PR. PR is equal to MN, and the value of MN is square is x2 minus x1 whole square plus y2 minus y1 whole square plus, now QR, the measure of QR from the construction is Z2 minus Z1. So let's substitute the value. So dear student, by substituting the corresponding values of PR and QR, we have got the value of PQ square. We have got the measure of PQ square, which is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Therefore, PQ is equal to So if we remove a square, then we get the measure of PQ. So if we remove a square from left hand side, then there will be root in the right hand side. So dear student, PQ, the measure of PQ, we have got x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, which is the distance between the given 2 points P and Q, which are in this space. So dear student, if you want to take this screenshot, you can take it. Next time we'll meet with a new content. Till then, bye. Have a nice day. Thank you.